Good morning, good afternoon, good evening, everybody. My name is Rohan D'Souza. I'm the Chief Product Officer at Olive. We're very excited today to walk you through this session on biomedical Q&As and knowledge graphs, more specifically what we've been doing in the AI space, very targeted in healthcare. I'm joined today by Ben Elbert, who's our Director of Engineering at Deep Purple at Olive, and a special shout out to our engineers that have made this possible and continue to work in the trenches of healthcare AI, specifically Greg, Ali, Bill, and obviously Ben, who's going to be talking today. So next. So a quick presentation outline. We are first going to tell you a little bit about who we are, what is Olive, what space are we specifically in, why are we really interested as a company in Q&A and in knowledge graphs, a little bit about our project overview, which Ben will be covering specifically around our guiding user stories and our proposed solutions, some details about our architecture, obviously some benchmarking results against our Bioass, and then finally some example questions that we asked ourselves and what we have subsequently learned through this process. So quick introduction about who Olive is. Olive as a company is primarily focused in the healthcare revenue cycle and operational space. We've entered the market. We've been in existence since 2014, really focused around building this vision of bringing the internet to healthcare. Our founder had this vision that today healthcare is mostly using humans as routers, and how do we apply technology, more specifically things that you're going to hear us talk about, which is knowledge graphs and attaching these mesh networks to really bring intelligence to the edge. We happen to find ourselves very much in the area of revenue cycle and operations. I realize that the majority of today's conversation is heavily focused around clinical applications, but the bulk of what we do is sort of in the dark corners of hospitals and revenue cycle teams, which is what you as consumers and patients don't end up seeing, which is a lot of the back-end processing that happens. We are fortunate to be funded by some well-known institutions like Drive Capital in our neck of the woods in Columbus, Ohio, GV, Silicon Valley Bank, Sequoia, Tiger Global, Dragoneer, General Catalyst, and Transformation Capital. And on the right side of the screen, you can see a lot of the areas in which we are applying our technology to solve some very eminent problems that exist in our day-to-day lives. The slide is pretty self-explanatory. We believe we are healthcare's leading artificial intelligence platform. Obviously, artificial intelligence is a very large and umbrella term. More specifically for us, we're the only AI as a service workforce. More specific, the reason why we use workforce is we don't think of Olive as a traditional robotic process automation provider. We really think of Olive as an extension of the human workforce, and eventually the ability to intelligently inform the human workforce to function more efficiently. And so we've coined this term of building AI as a service, whereas a workforce that is embedded within the trenches of healthcare that is constantly seeing a tremendous amount of variation in data that is flowing back and forth, and through that process is learning. We've engineered some pioneering techniques, obviously focused around robotic process automation, but over the years, because we have been seeing so much data, we are now informing a lot of the products that we bring to market by way of data that we are capturing in our day-to-day operations at some of the largest health systems in the country. And so some examples of this is we have over a terabyte of data, we have over 700 clinics, we have 1,400 enterprise automations that are currently happening, and there's some statistics around our NPSR deployed over the first years. And then on the far right, you see a vision or a screen of how we show all of performance to our end users. And before I turn it over to Ben for the meat of today's conversation, we care very deeply about knowledge graphs. We truly believe, as part of building the Internet of Healthcare, how do we present a world where we are living in an information surplus rather than an information desert. You know, we today in healthcare, we don't live in a data desert. We live in an information desert. And it is our job, and I believe our commitment to society, to provide this information capability all the way down to the edges of the trenches of call center representatives and the most esteemed clinicians that are performing the most complex surgeries in the world. So with that, I'd love to turn it over to Ben to take you into some of the details around our specific NLP and knowledge graph use cases. So Ben, with that, take it away.
Great. Thank you so much, Rohan. Yeah, as Rohan mentioned, a lot of our work that we're going to be talking about today is really in the space of how Olive is working to bring together deep learning, knowledge graphs, large, massive scale of data, and really distributing that across an ecosystem that allows us to start to look at how can Olive take all this information that she knows and start to provide back to our partner organizations and their staff members. The reason why we're looking at this is if you think of question answering as a graph itself, all too often the act of Q&A it leads to a terminal node. You pose a question, whether that's through something like a Google interface or through a custom built application. You pose a question, and all too often you do get an answer, and that's great. But that's where it stops. If you want to go further, you have to then do that on your own. You have to click through, you have to search, you have to ask more questions. Where we see this great opportunity is how can we take what already our teams are working on in the Q&A space with using deep learning, namely variants of BERT and others, and then not land at a terminal node, but rather land inside the graph. Knowledge graphs are great because they semantically link knowledge together through ontologies. We see this opportunity, and as such, the team has been working on how do we really do this end-to-end type cycle that allows us to build out both Q&A systems and then plug into this really rich, dense, and growing knowledge graph that we're building here at Olive. So why are we doing it, right? To Rohan's point, our goal is, as we build the internet of healthcare, we do believe that it really does help start to transform us from an information desert to an information oasis. And we look at the fact that even still in the 2020s that we are now, collating knowledge is often tedious. It requires lots of searching, lots of saving of items, lots of kind of manual connection. There are services, of course, Google, PubMed, others that do great at finding material, often even finding maybe biomedical or specialized information. But all too often, right, the links have to be followed by the actual user. We see that as a great opportunity for us. And then we recognize that this isn't just in the biomedical literature space, even though that's what most of our talk today will focus on. We also recognize that health systems, there's patterns in their data, their rev cycle data, their clinical process data. We can help there. And that's it's the things that Olive knows and what she can do. When we look at how the prior authorization pipeline that Olive has and how that connects patients and health systems and payers, so much of that underpins on document retrieval, on natural language processing and understanding. And ultimately what we're getting from this Internet of Healthcare is how we transform our petabyte plus scale of data into something that's semantically linked, and therefore far more than just data. It's knowledge. So why knowledge graphs? I probably set it up pretty well why we like knowledge graphs, but semantically linked data has all sorts of great benefits. First and foremost, we love that there is the ability to make inferences based on ontological reasoning. That's wonderful because it allows you to extend logic and reasoning in great ways and then transform what you know somewhere into what you know everywhere. It allows for strongly typed data contracts, and that is incredibly important across large distributed systems like what Olive is and who Olive works with. And then selfishly to this point, right, it allows for that easier follow-on navigation in an application where if you're given a node and it's one-hop neighbors, you can just start traversing from node to node. You can surface new insights, and that's great. The other beneficial part is that our brains function very similarly to the semantic web. So technologies, if they're designed right, feel intuitive. They feel like the way that your brain is already thinking, and that's a great thing. Got a little video here and just kind of show you just one of our engineers put something together just to give that visual. I'm sure a number of people are familiar with knowledge graphs, but if not, you can kind of see you've got nodes and edges, you got these subjects, predicates, and objects, essentially. They create these relationships, and as you can see, it lets you can link some to the next, and you can continue to follow those threads through, and that's where the real power comes from, is that ability to follow threads. So how are we going to solve the problem? Right? We're essentially building out these comprehensive biomedical and operational knowledge graphs. We could refer to it collectively as the knowledge graph, right? It's our combined resource. And as we do this, Olive contributes to the graph, Olive benefits from the graph, Olive makes recommendations, does things with the graph. And so getting a more robust information retrieval platform, a robust question and answering system, and then of course this growing dense and highly enriched knowledge graph brings these together to create world-class user experiences and world-class information sharing. So we can look a little bit into the weeds, and if we think of kind of what this high-level flow looks like, right? In this case here, for us, we're going to talk through how we've kind of used a competition like Bioass as our compass. You think about what goes into this, and it's the process of first just indexing a large amount of biomedical literature. In our case, loading and indexing over 30 million biomedical articles. We currently use Elasticsearch for some part of that, which is great because it allows us to do full text indexing and searching. But what we're able to do is actually build on top of that. And then we separately have our biomedical knowledge graph, both data that we've consumed as well as additional data that we've been able to procure, and that gives you these relationships and these rich opportunities. And so what happens is ideally, right, a user submits a query, and one of the first things that happens is the query is refactored and expanded. The reason being, all too often, the query asked can have more information to it, right? Users tend to say exactly what they're looking for, but often what they're needing to find maybe is tied to a synonym, or needs to have antonyms removed, or maybe needs to have certain words dropped in order to increase the relevant information retrieval, which is great. After retrieving that first pass of search results, we then do attention-based re-ranking. And so by combining re-ranking that can be done via our fine-tuned biomedical and then normal language models, we're able to re-rank results, which is really exciting because it helps get you to a point where you have a really robust search algorithm that is then augmented by a very fine-tuned search procedure. And then finally, it's linkage. So linking things that are identified in the responses, both the answers and the relevant passages, the citing of your source, linking those back to the biomedical knowledge graph, so that when the user gets their information back, they don't just get an answer, they get a doorway to more knowledge very quickly. All right, so we're going to talk a little bit deeper today, specifically about Bioass, namely what is called Bioass Part B, and how we use it as a compass, not as our entire guiding principle. Of course, you never want to overshoot for one specific competition or data set, but it does provide a great opportunity. It's currently ongoing at the time of this recording, and will, I think, be still going on or just wrapping up by the time we're actually at the summit. Bioask is this open challenge. It's held and organized by the National Center of Scientific Research, otherwise known as Demokritos, in Greece, and also with partners at the University of Houston. Every year, there are co-organizers from all around the world, and the high-level vision, right? I'm going to read it so I don't butcher it in paraphrasing, but the high-level vision all right, is that Bioass pushes for a solution to the information access problem of biomedical experts by setting up a challenge on biomedical semantic indexing and question and answering. I feel like we wrote that. It's something that all of us in the industry find very, very pertinent. So we go through and we're going to use this as an opportunity to test our systems. It's great because it does actually talk about how we augment search engines. It looks at how we can test our query expansion and refactoring, looks at multi-agent answering systems, which is great because it functions similar to a panel of experts, which is altogether very handy, very similar to ensemble modeling and other forms of machine learning. Real quick, I'll just show this and then I'll kind of go past it. But the Bioass dataset is very rich, includes a question, includes relevant documents, includes triples, the subject, predicate, object. So if you want to test out actually building your own graph, it's great there. Provides an ideal answer, which is a summarized or synthetic answer created by a human, not an extractive answer. We'll talk a little bit more about that here in a second. And then also includes, the exact answers, concepts if you're interested in exploring research that way, and then also has snippets from every passage that they believe to be relevant to that question. You can imagine, I'm sure those of you who are looking at this are saying, like, that's a wealth of data. And it really is. We're in year 9. We're just now starting to contribute, but it's been going on for 8 previous years. So lots of data available. And it's organized by biomedical experts across Europe, which is great because, it's a rich, curated data set. So as we've done some benchmarking against historical results, we see that right now, we're middle of the pack, I guess is the best way to put it. I'm very, very proud of the engineers for already reaching to that level after really just a short amount of time of work on Bioass specifically. But what's great is that organizationally, there's only a few other teams from last year that would have been ahead, 7 models, 5 teams. This, of course, is last year historical data. We have progressed. Everyone else has progressed as well. But it's exciting to see. You can see that there's great opportunities. And what I always like to see when I see graphs like this is that we're not 0. We'd love to be number 1. That's where we're aiming for. But it does give us that opportunity to see where can we improve and what can we do, which is really exciting. And then similarly against phase B, so phase A, as I mentioned earlier, is the information retrieval aspect. All right, it's how, given a question, what articles are pertaining to that question. And then phase B is, here's a question and here are the relevant articles. We're already going to tell you the golden standard for the articles. Of those, what is the correct answer? And there's different types of questions. There's list, which is just listing out of elements. There's factoid, and there's yes, no. Similar to some of the stuff that's been done with Squad or other more popular competitions like the Kaggle TF2 or the Kaggle Quora competitions that have happened in years past. But this narrows down, of course, to factoid, yes, no, and list, which is exciting. Again, here in the top third for Q&A itself against last year's results, and then our goal is really to look through and continue to improve that. The team this year, as we're recording this, actually phase A for batch 2 of 9B. It's a lengthy nomenclature, but that is actually going on today as we're recording, and then tomorrow will be phase B of batch 2, and there's 5 batches each year. So excited to get in on this and kind of see how we do each batch. All right, so let's spend a little bit of time here. I recognize this probably looks like a wall of text, but it's relevant, I promise, and I think it shapes actually a really great opportunity for us to talk about. Our goal is not the competition. Our goal is not a place on leaderboard. Our goal is to continue to build out Olive's AI capabilities. As a result, just doing well in a competition is not sufficient. In fact, the canon is strewn with lots of examples of competitions where teams that did middle of the pack or in the top 10 or things like that wind up producing significantly better systems. right? Winning the leaderboard isn't always winning what you're setting out to do. And so for us, our goal is to keep that in mind. So we thought of, let's look at some of the questions that we were both getting right and wrong according to the competition, and look at what it means and how to make sure that we're not over focusing on position and instead focusing on the right pieces. So for this, for instance, let's take the question from a past Bioass data set, which is, what is the aim of the radiogenomics consortium? The ideal answer that they provide in the data set is that it's for pre-identification of people who are at greatest risk for adverse effects resulting from cancer treatment using radiation. From the actual radiogenomics consortium website, it expounds on that a little bit further. Our answer, extractive, right? So not synthetic. We didn't use something like a generative model. Rather, this is extractive for citing your source. We looked through, and our answer back was, to share biospecimens and data so as to achieve large-scale studies with increased statistical power to enable identification of relevant genomic markers. And that is from a paper written about the consortium, and in a way is correct some way, but not necessarily. Again, not according to the competition. And ideally, right, we would have found some way to get that exact statement somewhere. That would have been even better. But when we look at it, what jumps out to us is that the ideal answer is a succinct summary of the statement, right? And if you build a system that can take the original site-based answer and generate that ideal answer, that's a great synthetic model, right? You're generating great answers. But with that becomes lots of problems. They've been raised by OpenAI in the GPT system, Turing, developed by Microsoft and others. They've all said that, right, these generative models, they pose risks because here you actually have, you could have a counterfactual or incorrect statement, but it sounds so right that most people will not question it, right? And that's top of our mind. Not every user of our system in the long run will be expert trained bioclinicians or researchers, right? You're going to have persons working in the hospital. You might have patients interacting with the system. You can't just sound right. You have to be right, right? So for us, this was a great thing when we saw it. I was like, it is a great example. Please note, in this, none of the statements are in fact counterfactual, but it does give a great opportunity to say that synthetic generated data or synthetic generated responses from the data, they do pose the risk of distillation of ground truth, right? We have to be always mindful of that in these systems. So let's look at another one, right? Another one is something like the Cyberknife, right? So the question was, what is the Cyberknife used for, right? Their ideal answer, their extractive answer in this case was Cyberknife is a robotic stereotactic radiotherapy system. I didn't do myself favors by choosing long phrases, but from their site, right, this is similar. They go into the different ways that it's used. And then our answer, drawn from the literature, was uveal melanoma, right? So our answer, of course, not correct necessarily in the data set sense, and it's definitely not complete in the sense. I think ideally, right, anyone would have loved a lengthier answer. But it actually brings up a really interesting point, which is if our goal is to try and connect things together, right? Answers like uveal melanoma is insufficient, right? So any Q&A system, even if that had been a correct enough answer, any system that just responds like that is not helpful, right? It's not going to give enough. And our links to the knowledge graph from that might completely exclude things relevant to the Cyberknife or to other technologies. So it's important to look at how, when you're answering for these data sets, are you giving yourself not just a good answer, but also a good enough answer to be useful in what you want to do, right? The goal is not the position, the goal is the application. And then finally, one last one. So if you consider the question, in which cellular compartment do stress granules localize? The ideal answer, cytoplasm. Our answer, cytoplasm, right? Yeah, great, we got it right. If you actually put that exact question into Google, You don't get an answer, and then you have to go down this really long journey, essentially, of like, cytosol versus cytoplasm versus all the other parts of cells, and it can be lengthy. And in this case, right, so we got the right answer, but unless this query was just trivial, or unless this query was just something of like, maybe I joked around, like maybe a bet amongst former biology students, right? This brevity leaves us wanting more. And that's why we're connecting our Q&A systems to our knowledge graphs, because that wanting more can be satisfied by jumping off from both the query, the relevant documents, the answer, and connecting to this rich web that allows you to jump from one to the next and say, well, who's writing about stress granules? And, oh, it's interesting, I didn't know that about the cellular compartment. Let me follow through and start to look more into the anatomy and physiology of these biomedical organisms. And you can see it there, but you can also see how that works, right, with an organization. You can see how it works with a process or a procedure. That is why knowledge graphs are so important to us, because we all have questions, we all have knowledge we want to gain. How do we then turn these really rich, robust AI platforms into knowledge-giving systems? And that's what we believe that Olive knows, and that's what we're doing. So just to wrap up, I do want to give a couple of special thanks. First and foremost to Costa and Danielle, our product managers in Deep Purple, have been incredibly helpful in guiding us where we're going. And then Rohan, who spoke with me today, David Landerman and Sean Lane. They're our CPO, CTO, and CEO, respectively. Since the time I've joined Olive, the questions that they ask, the conversations that I have with them, things like that, really generated us to a lot of this. I'm fortunate enough to work in an organization where two of my chief officers reached out and said, we're interested in GPT and saw that GPT-3 is coming out, curious, like, what could we do with that kind of technology? And we originally started down the generative path. We looked at that and we said, actually, cite your source is so much more powerful. So we kind of went to cite your source and using like BERT and BERT-based modeling. But it's great, right? We had that opportunity. So I will say it might be a shameless plug, but Olive, we are in the process of hiring. We're actually hiring a lot. So if these are the kind of problems that are interesting to you, whether you're in the practitioner space, if you're in the product space, if you're in the software engineering space, if you're in design, wherever you're at, we have lots of opportunities. Hopefully this is exciting to you, and we look forward to kind of sharing more over the next coming months and years as Olive just continues down this path of bridging not just data to knowledge, but knowledge to people via these Q&A systems. All right. Any questions?